Part 3, Horizontal Asymptotes. The line y equals c is called a horizontal asymptote of the graph of the function y equals f of x if, as x approaches negative infinity or x approaches infinity, f of x approaches c. So in this case, we can see that red dashed line is a horizontal asymptote. As x gets bigger, so approaches infinity, the graph gets closer and closer to that dashed red line. And as x approaches negative infinity, so as x gets smaller and smaller and smaller on the left, the graph starts to approach that red dashed line. So that red dashed line is the horizontal asymptote. This is the graph of f of x equals 1 over x, and the horizontal asymptote is y equals 0 because as x approaches negative infinity, f of x approaches 0. And as x approaches infinity, f of x approaches 0. If we use transformations to determine what would happen if we move this graph up 2. So the graph g of x equals 1 over x plus 2. If we move the whole graph up 2, the horizontal asymptote also gets moved up 2. So we would have the line y equals 2 for the new horizontal asymptote. So how do we find the horizontal asymptotes of rational functions? For r of x equals p of x divided by q of x, if the degree of p is less than or equal to the degree of q, then r has a horizontal asymptote. So if the degree of the numerator is less than or equal to the degree of the denominator, then there is a horizontal asymptote. If the degree of p is less than the degree of q, so if the numerator has a smaller degree than the denominator, the horizontal asymptote equals y equals 0. For example, if our function looked something like 3x over x squared plus 2x plus 1, the degree of the numerator is 1, the degree of the denominator is 2, so the degree of the numerator is less than the degree of the denominator, then we know our horizontal asymptote is y equals 0. 2, if the degree of p and q are the same, so the degree of the numerator is the same as the degree of the denominator, the horizontal asymptote is the line y equals the leading coefficient of p divided by the leading coefficient of 2. For example, if I had something like 3x squared plus 1 over 2x squared plus 4x plus 5. The degree of the numerator is 2, the degree of the denominator is 2, so the line y equals 3/2. Those are our leading coefficients. Y equals 3/2 is the horizontal asymptote. Remember, the graph of a rational function may cross a horizontal asymptote. The graph will not cross a vertical asymptote, but it might cross a horizontal asymptote. Let's identify the horizontal asymptote of the functions. F of x equals 2x plus 1 divided by x. So we look at the numerator and denominator. The numerator has degree 1. The denominator also has degree 1. So our horizontal asymptote is the line y equals 2 over 1. Our leading coefficient of the numerator is 2. Our leading coefficient of the denominator is 1. So y equals 2 is the horizontal asymptote. Note that f of x equals 2x plus 1 over x. We could rearrange it and end up with 1 over x plus 2. And on a previous slide, we said that if we have the graph 1 over x plus 2, we would end up with a horizontal asymptote as y equals 2. And that would be this graph right here. So let's identify the horizontal asymptotes of each of these. For g of x equals x plus 3 divided by x squared minus 16, the degree of the numerator is 1. The degree of the denominator is 2. So if the numerator has a smaller degree than the denominator, the horizontal asymptote is the line y equals 0. For h of x, x squared minus 16 over x plus 3, now we have the degree of the numerator is 2 and the degree of the denominator is 1. If the degree of the numerator is more than the degree of the denominator, there is not a horizontal asymptote. Now this particular function does have what we call a slant asymptote, but we will talk about that later. If we look at k of x, we have k of x equals 5x cubed plus 2x minus 13 divided by negative 2x cubed plus 5x plus 4. The degree of the numerator is 3. The degree of the denominator is 3. They are the same. So we look at the leading coefficients, and the line y equals negative 5/2 is the horizontal asymptote.